Good afternoon, again, Mike. Eco 3311. I've recorded part 1 of chapter 6, which is a chapter on the risk and term structure of interest rates. So let's finish it. There's only a few slides remaining. We talked about the expectation theory, which is one of the key theories economists put in place to explain why the three facts about interest rate on bonds, why interest rates move together, why, when the short-term bond interest rate is above the long-term bond rates, the yield curve is going to be downward sloping, but when it's below, the long-term bonds yield curve is going to be upward sloping, and why yield curve must almost always slope upwards. So we did that. So let me share my screen and we pick up from where we stopped. So this is going to be part 2 of chapter 6, which is towards the last end of chapter 6. Okay. So we talked about the limitation of expectation theory cannot explain why yield curves usually slope upwards. So we're going to talk about another theory, which is the segmented market theory. Remember, the expectation theory says that bonds of different maturities are perfect substitutes, as long as the return on them are the same. Investors are going to treat those bonds as perfect substitutes. If a 2-year bond has identical expected return as a 5-year bond, investors are going to close their eyes and buy either bonds. Okay. The segmented market theory disagrees with that. Okay, remember, so the segmented market theory is basically arguing that bonds of different maturities are not perfect substitute at all. It's like two theories that have drawn a leg or a line in the sand. One is saying that bonds of different maturities are perfect substitute. That was expectation theory. These ones are saying, no, they're not. So, so the exponent saying the interest rate for each bond with a different maturity is determined by demand for and supply of that bond, which they kind of have a point here. So the segmented market theory is saying, say, look, there are investors out there who only love buying long-term bonds. They fall in love with a 30-year, 20-year bond. And then there are those that only want to buy short-term bond, like 1-year bond, that even if you tell them about a 20-year bond, they're never going to buy it. Okay. So we'll talk about that. So and then investors have preference for bonds of one maturity over another. If investors generally prefer bonds with shorter maturities that have less interest rate risk, then this explains why yield curves usually slope upwards. So the one thing about the second, and that's it. That's the theory. It's basically so let me kind of expand this a little bit. This important theory is going to explain the third fact, which the expectation theory doesn't explain. So even though the segmented market theory is telling us that investors always prefer a bond of a different maturity over another, they are going to argue that for the most part, so segmented market theory. They're going to continue saying that for the most part, investors are typically risk averse because we saw in chapter 5 that interest rate risk is very important to knowing what bonds you're going to buy. Bond prices, long-term bond prices are very sensitive to what? To changes in interest rates. So if that's the case, for the most part, if investors are typically risk averse, that means they will prefer short-term bonds, because short-term bonds are not exposed too much to interest rate risk when you compare it to long-term bonds. So investors are going to prefer short-term bonds over long-term bonds. So if that's the case, we can draw the market here to represent the two bond market. Let's say there were two types of bonds here. I'm going to say we have, let's say we have short-term bond market versus long-term bond market. Short-term, I mean, like bonds that mature like 1 to 5 years. Long-term could be like 15, 10, 20 to 30-year bond. So this is a price of a short-term bond, PS, corresponding interest rate on a short-term bond. This is going to be the quantity. Like we always call that B. And then we're going to have this a market for long-term bonds here, which we can say if the price of a long-term bond versus interest rate on a long-term bond versus what? Quantity. So if investors are preferring short-term bonds over long-term bonds, it means that the demand for long-term bonds, so for short-term bonds, are greater than the demand for what? For long-term bonds. So let's say given a bond supply here, let's say this is a bond supply in the short-term bond market, this would be the demand for short-term bonds. The demand for long-term bonds, because it's small, is going to be very small. The smaller the demand curve, by the way, the steeper it is. So this is going to be the demand curve for long-term bonds, okay? So what does that mean? So if we embed a corresponding supply for long-term bonds, this market is going to reach equilibrium where the supply equals the demand. At this point, this is going to be equilibrium then this is going to be price of a long-term bond with interest rate on the long-term bond. Meanwhile here, because the demand is relatively bigger, the bigger the demand curve, the flatter is a demand curve. See, this demand curve is a lot flatter than this one. This one is much steeper. So this means because most investors are typically risk averse, they prefer short-term bonds. It means the demand for short-term bonds is going to be bigger than the demand for what? Long-term bonds. So this is going to determine the price of a short-term bond and a corresponding interest rate on a short-term bond. And as we said before, if you draw a line across here, you can see that the price of a short-term bond is going to be above the price of a long-term bond, meaning that the interest rate on a short-term bond is going to be lower than the interest rate on a long-term bond because we read interest rate and price in opposite direction. So let me repeat that again. So according to the segmented market theory, bond investors prefer a bond of a different maturity over another. But typically, they're risk averse. They prefer short-term bonds over long-term bonds. If they prefer short-term bonds over long-term bonds, it means the demand for short-term bonds is larger than the demand for long-term bonds. How do we know that? The larger the demand, the flatter it is. The smaller the demand, the more inelastic or the steeper it is. Okay, so this demand curve, which is very steep, depicts what we see in the market. It's very small. That's the demand for long-term bonds because investors are typically risk averse. They prefer short-term bonds over long-term bonds. Okay, so if that is the case, this is going to guarantee if the price of a short-term bond is always above the price of a long-term bond as depicted in this diagram, it guarantees that the short-term bond interest rate will always be below the long-term bond interest rate. And that is going to guarantee that the yield curve almost always slope upwards. Something which is fact number 3 about what? About interest rate on bonds. So that is going to guarantee that whatever I talked about there, that if I put yield to maturity versus time to maturity, it means that the yield curve is going to be upward sloping. Why? Because from the previous diagram, short-term bonds, like 1-year bond, interest rates are going to be lower. While interest rate on long-term bonds are going to be above. Okay, this is long-term bonds. Interest rates are going to be high. Long one. That's going to guarantee that the yield curve almost always slope upwards. That is a segmented market theory. It's basically a critique of the expectation theory. Because expectation theory says that interest rate. But now, there's nothing in this second theory which can explain the first 2 facts. The segmented market theory, because it's just a critique of the expectation theory, but yet it guarantees, it ends up explaining the what? Fact number 3. It cannot explain the first 2 facts about yield, about interest rates on bonds. Those first 2 facts say that what? Bonds of different maturities are what? Move together. Interest rate on bonds of different maturity move together. That can't be explained by the segmented market theory. And it cannot explain the fact that when short-term bond rates are low, the yield curve is most likely going to be upwardly sloped. And when they're high, the yield curve is most likely going to be downwardly sloped. That can't be explained either. So that means the segmented market theory, which is a critique of the expectation theory, can only explain the what? The third fact about the yield curves, but it cannot explain the first 2. Okay. So now we have established 2 theories. One, which is expectation theory, which can explain the first 2 facts. The second theory, which is a critique of that expectation theory, that's the segmented market theory, can explain the third fact, which the expectation theory cannot explain, but it can't explain the first 2. But we need a theory that can explain both, all the 3 facts. Then we went back to the drawing board and we came up with a better theory, which is called the liquidity premium and preferred habitat theories. Okay, so the word preferred habitat here basically is like your preferred home. The key idea here is that about preferred habitat is talking about bond market. There are different types of bond market: 1-year bond, 2-year bond market, 5-year bond market, up to 30-year bond market. So if a 30-year bond market is a bond that you like investing as an investor, then the 30-year bond market is your preferred home, is your preferred habitat. If a 5-year bond or a 2-year bond is what you love investing in, then a 2-year bond is your preferred habitat. Okay. So the liquidity premium basically says that, theory says that the interest rate on a long-term bond will equal an average of the short-term interest rate expected to occur over the life of a long-term bond, plus a liquidity premium that responds to supply and demand conditions for that bond. So when you read this definition of liquidity premium theory, it's the same as for expectation theory up to this point, wherever I'm blocking out. That's how we define the expectation theory. But we're just going to continue on with the definition of the expectation theory, then plus a liquidity premium that responds to supply and demand conditions. So according to the liquidity premium, most investors want to invest in what? In a short-term bond market, right? So say, based on the liquidity premium theory, most investors prefer short-term bonds over long-term bonds. The question is, how can we convince them? How can we convince investors to start buying longer-term bonds, longer-term maturity bonds? The answer is we need to compensate them, pay a liquidity premium. Okay? So the idea here is that liquidity premium on short-term bonds are always very small or even non-existent. Okay? So if you have like say a 2-year bond, a 5-year bond, a 10-year bond, a 15-year bond, 20-year bond, and a 30-year bond. We are gonna okay, you're gonna start with a 1-year bond. The 1-year bond typically has almost have 0 liquidity premium. If you buy a 1 year bond, nobody's going to pay you a liquidity premium. Liquidity premium is paid to you to convince you or to make the long-term bonds more attractive. Meaning that the liquidity premium is additional interest rate that you get from investing in a long-term bond. So, and it starts paying at what L2. So we're going to define L2T, define L5T, L10T, L15T, L20T, and L30T. So these are what? These L's, this is what we're calling liquidity premiums. And it's going to be less. The liquidity premium for investing in a 2-year bond is less than the liquidity premium in investing in a 5-year bond. And liquidity premium for a 5-year bond is less than the liquidity premium on a 10-year bond, and so on and so forth. In other words, the liquidity premium increases as the time to maturity, what time remaining to maturity increases. So that means the formula for the liquidity premium is not different. It's not a lot different from the formula. We're not going to derive any other formula anymore because it's a definition of the what? Expectation theory, but we're just going to add a liquidity premium. So we're going to write this as we're going to say, in general, the liquidity premium formula. The interest rate on any year bonds in general, NT, is going to be the average of the short-term interest rate as before. It's going to be I, T plus 1 expected, plus IT plus 2 expected. This is going to go up to IT plus N minus 1 expected. We divide all this by N, but then we have to add a liquidity premium on any year bond. So when we wrote the formula for the expectation theory, this last term was not there. That L and T wasn't there. Okay? So the L, because one of the reasons why we are adding the liquidity premium at the end is because that liquidity premium, which is always a positive number, is going to guarantee that longer maturity bonds pay a higher interest rate. And that's going to ensure that the yield curve is upward sloping, almost slope upwards. Something that the expectation theory could not explain. Because the liquidity premium rises, as I said, with time to maturity. Okay? So if that is the case, then this is in general. Then that means for, no, let's summarize it now. Then we do an example. So that basically means that for, acting up again. Start from here. So we're going to say for N, what's wrong with this pen? Stop reading the signal. It's crazy. For N equals to 2, that means 2-year bonds. According to the liquidity premium theory, the liquidity premium, the interest rate on a 2-year bond, because this is in general for any year bond. What about for 2-year bonds? That means we need to add the interest rate on a 1-year bond today plus the interest rate on a 1-year bond expected 1 period from today, divide by 2. Then we're going to add the liquidity premium from holding a 2-year bond. You got to be careful here, though. The liquidity premium, L at L2T, this is a liquidity premium from holding a 2 that you get paid for holding a 2-year bond over a 1-year bond. So this is a liquidity premium. Okay, that this liquidity premium part is not part of this ratio, part of this average. You must first average the interest rate, then you add the liquidity premium. Okay, and then 2 for n equals to 3, which is basically 3-year bonds. The liquidity premium formula is going to, for a 3-year bond, is going to be I3T must equal to IT plus IT plus 1 expected plus IT plus 2 expected divided by 3. And then you're going to add the liquidity premium for holding a 3-year bond. Then we can go to 3. For n equals to 4. That means the interest rate on a 4-year bond based on the liquidity premium is going to be the average of the 1-year bond interest rate today plus the expected 1 year from today, 2 years from today, 3 years from today, divided by 4. Then you're going to add the liquidity premium from holding a what? 4-year bond. Then 4 for n equals to 5. The interest rate on a 5-year bond based on the liquidity premium is just going to be the averages of these short-term 1-year bond rates for 5 periods. So LT plus 2 expected, T plus 3 expected, T plus 4 expected, divide by 5. Then you're going to add the liquidity premium for holding a 5-year bond. So let's do an example. The example is going to clear this thing up. So we're going to say premium. Theory. So we're going to say, suppose a 1-year bond has a series of interest rate given as %, 3%, 4%, 5%. Let's use the same example that we use for the expectation theory, 7%, with corresponding liquidity premiums given as 0%, 0.25%, 0.5%, 0.75%, and 1%. Okay, then I say, using the liquidity premium theory, calculate the yield on Roman 1, so this is part A, 2-year bonds. Roman 2, 3-year bonds. Interest rate then Roman 3, 4-year bonds. And Roman 4, 5-year bonds. And then B, plot the resulting yield curves. So yield curve. So, okay. So when you go back to this, excuse my handwriting, looks like chicken feed here, but I hope you can see it. If you go back to this formula, is this whatever? So when I say, suppose a 1 year bond has a series of interest rates given us, that means this first term here, that would be the interest rate on a what? Let's do it. This would be the interest rate. This would be IT. This first term. This would be IT plus 1 expected. This would be IT plus 2 expected. This would be IT plus 3 expected. And this, the last term here, 7 would be IT plus what? 4 expected. Just like we did for expectation. And then when we say they have corresponding liquidity premiums given as this, this is going to be LT. There's a liquidity premium on a 1 year bond. But for the 2 year bond, this is L2T. This is L3T. This is L4T. And then this last one for 1% is L5T. That's what the liquidity premiums. Okay. So to calculate, so we go, since we know that already, then everything is easy. We know the formula for the liquidity premium theory. So to calculate the interest rate on a 2 year bond, which is Roman 1, using a liquidity premium theory, we know that I2T is given as IT plus IT plus 1 expected divided by 2. Then we add the liquidity premium from holding a 2 year bond. And this is going to be the same thing. I2T equals to, we're going to average the first 2 interest rate given in the formula, in the problem, which is 1% and 3%, because it's IT, this IT plus 1 expected. I need those first 2. So that's going to be 1% plus 3%. Then I'm going to divide that by 2. Then I'm going to add, after dividing by 2, then add the liquidity premium on a 2 year bond, which is given the problem as 0.25%. Okay. So that means, based on the liquidity premium theory, this is going to be equal to 1% plus 3% by 2% is 2% plus 0.25%. So I2T is going to be equals to 2.25%. Very easy. Very easily done. Okay. And then Roman 2, the interest rate on a 3 year bond, that's what it was asking. So using a liquidity premium, I3T equals to, I3T equals to IT plus IT plus 1 expected plus IT plus 2 expected divided by 3. Then you add the liquidity premium for investing in a 3 year bond. So when we substitute this, what do we know? So the series of interest rate here are going to be given as that. So that means the first 3 is what we are averaging. IT plus 1, stop here. IT plus 1 expected plus IT plus 2 expected. That's right. So which is going to be, the 1% plus the 3% plus the 4% divided by 3 plus the liquidity premium from holding a 3 year bond, which is given as 0.5%. So you get 1 plus 3. This is going to be 8 out of 3 divided by 8 divided by 3 is 2.67. 2.67 plus 0.5. That's going to give me what? Let's go here. 2.67 plus 0.5, 3.17. So that means your I3T is going to be 3.17%. Pretty easy, pretty straightforward. Okay, and then let me get more room here. So Roman 4, no, so Roman 3. No, actually, yeah, Roman 3, yes. The interest rate on 4-year bonds, which is I4T. So that's going, the logic is going to be IT, the average 4 interest rates here on 1-year bonds. So this is going to be IT plus 3 expected, then not 2, plus IT plus 3 expected, divide by 4. Then you're going to add the liquidity premium for holding a 4-year bond. So your I4T, so you're going to average the first 4 interest rate here, IT plus 1 expected, IT plus 2 expected, IT plus 3, these first 4, which is given as 1% plus 3% plus 4% plus 5%. And let's divide that by 4. Then add the liquidity premium from holding a 4-year bond, which is given as 0.75%. Okay. So your I4T is going to be equals to 1 plus 3 plus 4, that's 8, 8 plus 5, that is 13, 13 divided by 4. 13 divided by 4 is going to be 3.25. Then you add this to the 0.75. So that's going to be 4%. So your I4T is 4%. Okay. Then the last one, interest rate on a 5-year bond, which is the I5T. So Roman 4 is your I5T, which is just going to be interest rate on a 1-year bond today, plus interest rate on a 1-year bond expected 1 year from today, plus interest rate on a 1-year bond expected 2 years from today, plus interest rate on a 1-year bond expected 3 years from today, plus interest rate on a 1-year bond expected 4 years from today. You divide this by 5, right? Then you add the liquidity premium on a 5-year bond. So your I5T is going to be now all those interest rate, average all of them, 1, 3, 4, 5, and 7. So that's going to be 1% plus 3% plus 4% plus 5%, then plus 7%. Divide by 5, plus the liquidity premium on holding a 5-year bond is given as 1%. No problem. So your I5T is going to be 1 plus 3 plus 4 plus 5 plus 7 divided by 3 is what? Is 4% plus the 1% here. That's going to be 5%. Your I5T is 5%. Okay. And then part B says we should plot the resulting yield curve, which is an easy thing to do. B, this is going to be the resulting yield curve. Yield curve, we plot a combination of YTM on the vertical axis, or yield to maturity, or interest rate, versus time to maturity. So we have been given 1-year bond interest rate. We said it was 1%, right? Given in a problem. Then we calculated interest rate on a 2-year bond. We found it to be 2.25%. Interest rate on a 3-year bond, which we found to be 3.17, I believe. Interest rate on a 4-year bond, which we found out to be 4%. So you're getting these points, 4-year, and then 5-year bond, we found it to be 5%. This is a rough plot. So that yield curve is going to be upward sloping. That's the resulting yield curve from that yield calculation. Straightforward. So what have we learned from here? If you go back to these formulas, the interest rate predicted by the liquidity premium theory is always going to be higher than the interest rate predicted by the expectation theory. If this, for example, on a 5-year bond, if I had asked you to calculate the interest rate on using an expectation theory, that interest rate would be 4%, because the expectation theory will stop here. We don't add the liquidity premium. So we're just getting the average, which is 1 plus 3 plus 4 plus 5 plus 7 divided by 5. So by the expectation theory, the 5-year bond interest rate would be 4%. But because we're talking about the liquidity premium, we have to add the liquidity premium to that for investing on a 5-year bond. So that brings it to 5%. So what have we learned? The interest rate that is predicted by the expectation theory, by the liquidity premium, is higher than the interest rate predicted by the what? Expectation theory. And we can look at it in terms of this diagram here. Okay, so the difference, okay, so if this is a black line here is the interest rate that is being predicted by the expectation theory, the blue line up here, that's the interest rate predicted by the what? Liquidity premium theory. So the difference in those two interest rate prediction gives you the liquidity premium, because we are only adding the liquidity premium. And you can see that gap gets bigger and bigger. The liquidity premium gets bigger and bigger, this gap, as the time remaining to maturity increases, because that's what we said. We pay a higher liquidity premium for bonds with longer term maturity. So a 30-year bond, a bond that matures in 30 years is going to pay a higher liquidity premium than a bond that matures in 25, and a bond that matures in 25 pays a higher liquidity premium than a bond that matures in 20, and so on and so forth. Okay. That the good news now is that with the because remember the expectation theory could not explain the first fact. Sorry, the third fact. It could explain the first two, but because we are combining the expectation theory and the segmented market theory, and we are adding a liquidity premium towards the end, the liquidity premium is gonna guarantee that bonds of higher, longer term maturity gets higher interest rate than bond with shorter term maturity, to guarantee that the yield curve almost always slope upwards, which is the third fact about interest rate on bonds. And so these are the things. So we explain all the three facts. This is just a few, whatever. If you want to go, these are just basically diagrams giving you how if the yield curve is upward sloping and is steeper, we call it steeply sloped yield curve. Then this is mildly sloped. And then we have the ones that are more like flat, and then the one which is sloped downwards, but really too elastic there. And then the last slide here is giving you the time. Remember I said that yield curves are typically upward sloping. Rarely do we find yield curves that are flat or horizontal or slope downwards. In fact, we can count the number of times that ever happened in the history of the US stock market and bond market. Like you see, when we woke up on January 15, 1981, the yield curve was flat, meaning that short-term bond interest rates were identical to the long-term bond rates. And then again on March 28, 1985, and then on March 16, 1980, on March 3rd, 1997, February 6, 2006. Well, these ones are relatively upward sloping already anyway. Yeah, but they still look a little bit flat. Okay. So this is it for this chapter. So so there are two parts of chapter 6. This is a shorter version part of it. So make sure you watch both videos. I'm going to be uploading them at Canvas. And then I'm going to be assigning homework number 3, which is based on chapter 6. Okay. This afternoon, I'm also going to record another lecture, which is going to be based on chapter 8, which I will post at Canvas as well. And I'm going to assign homework quiz 3 based on that chapter. Okay. So till then, let's talk another time. Thank you very much. Bye-bye.